Okay, Professor David J. De Los Reyes. Okay, my topic for this morning will be a random topic on long video format. This will be a topic on analytic geometry. Okay, let's proceed. I will try to read the problem. A circle in the xy plane has its center at the location of the center is at the coordinates 4 and 0 and has its radius endpoint at the location 1 and 4. Find the equation of the circle. Okay, I will try to discuss first the circle so we could visualize the solution of the problem because without the figure, it's hard to visualize. This is the xy plane. X-axis, y-axis, it's a plane, right? The center of the circle is at 4 and 0. 1, 2, 3, 4. This is the origin. The location of the origin is actually at 0, 0. Okay. The center of the circle is at 4 and 0. So this is 1, 2, 3, 4. Meaning the abscissa is 4 and the ordinate is 0. So sorry for this one. The location or the coordinate of center is at 4, 0. This one here. It says from the problem that the endpoint of the radius is at the location 1 and 4. This will be the radius, and according to the problem, the endpoint of the radius is at the location 1 and 4. This 1 and 4 actually lies on the circle, and it specifies that the location, the coordinates is actually at the location 1 and 4. This is 1, abscissa is 1, the ordinate is 4. Okay? This is 1 unit, and the height is 4 units. So the endpoint of the radius, this is the radius, is at the location 1 and 4. And the problem is asking what will be the equation of the circle. Okay, let's try to bring out the solution. At least we now know the figure, right? This is the center of the circle. The endpoint of the radius is at the location 1 and 4. Okay, what will be the equation of the circle? Okay, let's try to bring out the solution. From the study of analytic geometry, the equation of a circle with center at hk and radius r is actually represented by this equation here. X minus h quantity square plus y minus k quantity square is equal to r square. That is the equation of a circle with center at hk and radius r. Okay? Substituting now the value of the center, okay? For the meantime, we do not know the value of the radius. So if we try to substitute this, the coordinates of the circle, center of the circle, back to the given equation here, what will come out? It will be an x minus h quantity square. This h here refers to 4, right? Plus y minus k. And here, h is equal to 4 and k is equal to 0. So going back to this, it will be x minus h minus 4 quantity square plus y minus 0 quantity square is equal to r square. If we try to simplify this one, it will be an x minus h quantity square. This is now 0, right? So it will just be simply y square now equal to r square. This is now the required equation of the circle. Okay, the one the problem is asking for it, but the problem is the radius is unknown. Okay, so to bring out the solution, the equation of the circle, we must have to compute for its radius. Okay, let's try to bring out some annotation over here. Uh, this has been my favorite subject in college, right? Analytic geometry, because one of my professors was actually one of the best professors in the Philippines, and I still remember the solution of this one. It got an annotation something like this: the endpoint of the radius, which has coordinates 1 and 4, lies on the circle, right? So it must satisfy the equation of the circle. That's the explanation of my former professor, and up to now, I graduated 1977, so how many years will that be already? But till now, I still remember it, that if the point lies on the circle, that point should satisfy the coordinates of the circle. And here, the coordinates 1 and 4 lies in the circle, so this abscissa and ordinate must satisfy the abscissa and ordinate of the required circle. Okay? Just take note of that. If a point lies on the circle, right, these coordinates here must satisfy the x and y of the required circle. That will not change. Okay? It must satisfy the coordinates or the abscissa and ordinate of the required circle if it lies on the circle. So to compute for the radius r, we must have to use that annotation. Actually, that's the key to the solution of the problem. If a point lies on the circle, the coordinates of that point must satisfy the abscissa and ordinate of that circle. Okay? So if we try to bring out this equation here, which is x minus 4 quantity square plus y square is equal to r square. This x here and y, since this point lies on the circle, this 1 and 4 must satisfy this x and y respectively. Okay? To compute for r. So actually that's the key to the solution. So substituting now. Since x equal to 1 and y equal to 4 lies on the circle, this x and y must satisfy this x and y here. So we will take this value x equal to 1 and y equal to 4. We put it in the circle. It must satisfy because it lies in the circle. So substituting it now, this should be 1 minus 4 quantity square plus 4 square is equal to r square. We replace this x here by 1, okay, and we replace this y here by 4. Why? Because those 2 points actually, or those 2 coordinates lies on the circle. Okay, that's the concept over there. So 1 minus 4 quantity square plus 4 square is equal to r square. So after the substitution, okay, hola, the only unknown now is the radius r. So this will be 1 minus 4 is actually minus 3 quantity square plus 4 square equal to r square. Minus 3 square, okay, you apply the so-called laws of exponents under algebra, it will be a negative times a negative will be a positive 9. A positive 4 quantity square will be a positive 16. And this should be equal to r square. 9 plus 16, okay, we do not need PEMDAS over here. It will just be simply 25. The only operation on the left is addition, so we go directly to addition. So 25 is equal to r square. Taking the square root of both sides, we raise both sides to the 1/2. The square 25 to the 1 half is 5 units, and r squared raised to the 1 half, these two here cancel with this, so what remains on the right will be r. So r now will be 5 units. So the unknown radius of the circle, okay, is actually 5 units. So if we now try to bring out the equation of the circle, we'll go back to this. Because we now know the value of r, we just substitute it. So it will be an x minus 4 quantity square plus y square, same as that one, but we now know the value of r square from this annotation. Okay, it will be 5 quantity square. Simplifying this one, it will be an x minus 4 quantity square plus y square is equal to 25. This is the required equation. The key to the solution is this: the endpoint of the radius lies on the circle, so the coordinates of the endpoint must satisfy the circle. Okay, good evening from, or good morning from Los Angeles. This is Professor David J. Villasrey.